Hi, this is video 168 on financial math problem solving for Actuarial Exam 2. As you can see in this video, we're going to look at problem 7.1.12, a starred problem in Broverman. It's about rebalancing a portfolio of two bonds to change its Macaulay duration to some predetermined value that's going to be between the Macaulay durations of each bond individually. I think this will be the last video that we do that's directly about duration. We're going to move on to asset and liability matching and immunization, hopefully in the next video. I also want to remind you, as I've been doing in recent videos, that I've got a new blog that I made here in January of 2019. Infinity is Really Big, Bill Kinney's blog on mathematics, applications, life, and Christian faith. I would encourage you to check it out. I've got a lot of articles already about financial math and real analysis, and there'll be plenty of other topics to come. All right, let's come back to the problem at hand. So, taking a look at the problem, you can see it's kind of long here. First of all, it is assumed that the term structure of interest rates is flat. Okay, so that's just going to basically say we're in the simplest situation that we typically think about. In the very last video, we did think about term structures a bit, but that's not the usual case for most of the problems on this subject. The yield on zero coupon bond of any time to maturity is J per year. We're assuming these coupons are yearly. An investor owns a portfolio of two bonds. That doesn't mean that he owns just one of each bond individually. He's got maybe 20 of one bond and 15 of another. And they've got two different present values. The present values of the first is 50,000 and also two different Macaulay durations. The Macaulay duration of the first is 8 years. The second has a present value of 30,000 and the Macaulay duration of 6 years. Okay? The investor would like to rebalance the portfolio, switch things around, to change the Macaulay duration, evidently, so that it becomes 7 years. Now, we don't know what the Macaulay duration of the current portfolio is. That's not told to us, but evidently it's not exactly 7 years. It should make sense that it's between 6 and 8, but evidently it's not exactly 7. How is this rebalancing done? It's by selling some of one bond to decrease the holding of that bond, and using the proceeds, the money that you make from that sale, to buy more of the other bond to increase its holding. The total value, the present value, the price of the combined portfolio will still be 80,000. It's currently 80,000, 50,000 plus 30,000 after rebalancing. The question is, what is the correct action to rebalance the portfolio? And if you look in Broverman's book, you'll see that there are choices given. I think it's 5 choices, but we're just going to figure out what the answer is. I want to approach this problem in 2 ways. Well, we want to solve the problem first, but I want to solve it in an intuitive way first. What just makes intuitive sense, okay? And you should certainly develop such intuition, and it should make sense to you, and it's certainly the quickest way to solve the problem. That'll be the first part of the video. In the second part of the video, I want to try to mathematically justify that intuition. That'll be the harder part of the video. And maybe you're just after the intuitive answer, and that's fine if that's all you're after. All right, let's use some notation here. Let's say Dmac, comma 1 is the Macaulay duration of the first bond. Again, that wouldn't just be one bond that you bought, but of that type, but maybe 15 or 20 of them combined. But they all individually have the same duration, so it should make intuitive sense that the combination also has the same duration of 8 years. And the Macaulay duration of the second bond, or group of those bonds, at the yield rate J is 6 years. So that's a couple things that we know. Let's also write down the present values of each of those bonds, again, which are made up of individual versions of those bonds. P1 of J is 50,000, and P2 of J is 30,000. All right, let's first figure out the Macaulay duration of the portfolio in total. Dmac tot, and it's at this point that we're really going to use our intuition. Okay, I'm going to write down an equation that should intuitively give us the right answer, though it's not a proof. I'm not mathematically proving that this is the right way to go. That's for the second part of the video here. So what should make intuitive sense? I hope it makes intuitive sense that Again, the answer should be between 6 and 8. And it's probably closer to 8 because the monetary value as a present value of the first bond is higher than for the second. So the Macaulay duration of this portfolio as it stands should be closer to 8 than it is to 6. It should be 7 point something. To be a little bit more specific, it should make sense that if you take the ratios of the prices of each bond individually to the total price, the total present value, that maybe should be the weight in front of each individual duration, and then you add the results. Take a linear combination, it's called. So that would mean doing 50,000 divided by 80,000, which is the total price of the combined portfolio, which of course does simplify to 5/8, but let me leave it like that for the moment. That's going to get multiplied by the Macaulay duration of the first bond, 8. And then add the ratio of the present value of the second bond with respect to the total present value of both bonds combined for the portfolio, 30,000 divided by 80,000, and multiply that times the duration of the second bond, 6. Okay? I hope that makes intuitive sense. This is a weighted average, you could say, where the coefficients, the weights, do in fact add up to 1. They are the fractions for each bond of the price of that bond, the present value, with respect to the total present value. Of course, 50,000 divided by 80,000 does in fact simplify to 5/8, and 5/8 times 8 is 5. And then 30,000 divided by 80,000 simplifies to 3/8. 3/8 times 6 would be, well, the 6 and 8 would cancel. It would be 3/4 times 3, which is 9/4, or 2.25. If you can't do that quickly in your head, that's something you'll want to think about. 5 plus 2.25 is 7.25 years. That's the current Macaulay duration of this portfolio as it is. Okay? We want to reduce the duration to 7 instead of 7.25. You know, what's the purpose of that? The purpose would be to reduce our duration risk. Okay, the lower the duration, the less prone you are to duration risk, which means the less prone you are to the price of your portfolio to changes in interest rates. That can be a good or bad thing depending on the situation, depending on whether interest rates rise or fall. All right, so what should we do here? We have an unknown to solve for. Let's let x be the monetary amount. Monetary amount is what that says. A little hard to see the R there. Of, well, what should it be? We want to reduce the duration. We want to make it closer to 6 than it is. We want to buy more of bond 2 and sell some of bond 1. Let's let x be the monetary amount that we sell, of bond 1 that we sell. And that would, of course, then, by the statement of the problem, be the same as the monetary amount of bond 2 that we buy. I won't bother writing that to save some time here. Okay? Now again, this is a monetary amount, and if we algebraically solve for x, which we will do here, we'll get an answer, and you may not actually be able to sell that exact amount of bond 1. You know, maybe the price of each individual piece of paper for bond 1 that you buy from the government or from the corporation has a present value of 976.43 or something like that, and if x turns out to be 5,000 or something, you can't sell the exact right number of bonds to make it match x. But just think of it as an approximation to what goes on in real life. I guess that's perhaps the best way to think of it. So we want 7 to be the new Macaulay duration of the new portfolio. And here's why I left it as 50,000 divided by 80,000 and 30,000 divided by 80,000, because if x is the monetary amount that we sell of bond 1, the new present value or price of bond 1 is going to be 50,000 minus x, not 5 minus x. We still divide by 80,000. That gets multiplied by 8, and the new price or present value of bond 2 will be 30,000 plus x divided by 80,000 and multiply that times 6. So that's a linear equation in x that can be solved pretty easily. Let's first simplify this to one fraction. We already have a common denominator of 80,000. 8 times 50,000 is 400,000. 6 times 30,000 is 180,000. 400,000 plus 180,000 is 580,000. Then we have minus 8x plus 6x, that'll be a minus 2x. Multiply both sides by 80,000 and you will get 560,000 equals 580,000 minus 2x. So 2x is 580,000 minus 560,000, which is 20,000. And that says x is 10,000, and that indeed is the answer. That would be the monetary amount that you should attempt, if you can, to sell a bond 1 and use that money to buy more of bond 2, at least approximately. Again, you probably wouldn't be able to do that exactly. All right, so that's the answer. That's the first part of the video. On to the second part here. We want to now verify mathematically that this is the right thing to do. And so the key thing to verify, really, if you think about it, is that the Macaulay duration of the total portfolio is a linear combination of the Macaulay durations of each bond individually, where the coefficient is a fraction, that is the present value of each bond individually with respect to the total present value of the portfolio. Those numbers are fractions between 0 and 1. They add to 1. Let's see how that happens. There's two key things that we need to do, and what I'm about to do does mimic what you'll find in the reading in Broverman. You need the relationship between the Macaulay duration and the modified duration, and ultimately the relationship between the Macaulay duration and the price, present value, as a function of j. And you also need the fact that the derivative of a function of j in this case is a linear operator. So the derivative of a sum is the sum of the derivatives. You need those two facts here. Let's start to write it out. So the Macaulay duration, comma tot, for total, of j is, well, we've talked about this before. We know the modified duration is the Macaulay duration divided by 1 plus j. Therefore, the Macaulay duration would be the modified duration times 1 plus j. This is 1 plus j times the modified duration in total as a function of j. By the definition of the modified duration, we know the definition is that the modified duration is the price, the negative of the derivative of the price divided by the price as a function of j. The negative of the rate of change, negative of the relative rate of change of the function p of j. Another way to say that is the relative rate of decay of p of j. Okay, then maybe that was a little confusing to follow. I'll write it down here. I could write it as negative, well, the 1 plus j needs to stay there. 1 plus j, then the modified duration would be p prime of j divided by p of j. So the 1 plus j stayed there. The modified duration is negative p prime of j divided by p of j. You could call that the relative rate of decay of p of j. It's actually a positive quantity because p of j goes down, right? As j, the yield rate goes up, the price will go down. P of j here really represents the sum P1 of j plus P2 of j, because it's a portfolio. Okay, so that's the definition of modified duration plus the relationship between the Macaulay duration and the modified duration that we already know. Now we use the fact that the derivative, the prime, is a linear operator. P prime of j is P1 prime of j plus P2 prime of j. So I could write this. Should I write a P1 of j plus P2 of j in the bottom? I could, but I'll just leave it as a P of j, where I just remind myself this is the case here. Okay. What's my goal in this? My goal is to ultimately show that this can be written as a linear combination of dmac1 and dmac2. It's not completely obvious how that's going to be the case. The key is to sort of use the exact same relationships that we used up on this top line down here now. And let me also multiply the negative 1 plus j through. Let me first do this. Negative 1 plus j times P1 prime of j minus 1 plus j times P2 prime of j, all divided by P of j. And I can relate those products on top with the Macaulay duration. Look at this equation. Look at the equality between this and this. If you were thinking about the total portfolio and you multiply both sides of this by P of j, canceling it on the right side, you would have a negative 1 plus j times P prime of j equaling P of j times the Macaulay duration. That works for the total. It also works for each bond individually in the portfolio. I've got a negative 1 plus j times a P1 prime and a negative 1 plus j times a P2 prime. So I can replace those with the corresponding P1 of j and P2 of j times the corresponding Macaulay duration. Here's what I mean. P1 of j times the Macaulay duration of bond 1 of j. That product equals this right here. Same reasoning as what you see up here. And then this product, negative 1 plus j times P2 prime of j, equals P2 of j times the Macaulay duration of bond 2. And now we are getting very close to being done. This is a sum. This is a fraction where the top is a sum. I can break it into two fractions. Let me write it like this. P1 of j divided by P of j times d mac, comma 1 of j plus, oh, this is a prime here, sorry. No, not a prime, sorry. Plus P2 of j divided by P of j times d mac 2 of j. And that does it. That is the exact same kind of thing as what you see up here, over here. You've got a linear combination of each Macaulay duration individually, dmac 1 and dmac 2, that's the 8 and the 6 up here. You've got these ratios, P1 of j divided by P of j is the 50,000 divided by 80,000, and P2 of j divided by P of j is the 30,000 divided by 80,000. So that, in the case of a portfolio that's a combination of two different bonds, is a justification of the method. This does generalize to 3 or 4 or any finite number of bonds. The same kind of technique would work. This intuition that the Macaulay duration of the combined portfolio is such a linear combination is correct. Thanks for watching.